For over 180 million years, dinosaurs ruled the Earth. These magnificent creatures dominated the land, sky, and even the waters, leaving an indelible mark on the history of our planet. They were the undisputed masters of the land, their presence felt in every corner of the globe. From the dense jungles to the arid deserts, dinosaurs adapted to a variety of environments, showcasing their incredible versatility. From the mighty Tyrannosaurus rex, a fearsome predator with a powerful bite, to the gentle giants like Brachiosaurus, which towered over the landscape as they grazed on treetops, dinosaurs came in all shapes and sizes. Each species had its own unique adaptations that allowed it to thrive. They thrived in lush forests, vast plains, and even near the edges of ancient seas. Their ability to exploit different habitats was a key factor in their long reign. The Mesozoic era, often referred to as the Age of Dinosaurs, was a time of incredible diversity and evolutionary success. This era saw the rise of countless dinosaur species, each more fascinating than the last. Dinosaurs evolved into a dazzling array of forms. Some were ferocious predators like the velociraptor, known for its speed and cunning hunting tactics, while others were peaceful herbivores such as the Triceratops, which used its impressive horns and frill for defense rather than attack. Some were massive, weighing dozens of tons, like the colossal Argentinosaurus, one of the largest land animals to ever exist, while others were small and agile, like the Compsognathus, which could dart through the underbrush with ease. Their success was due in part to a warm, stable climate, abundant vegetation, and relatively few natural disasters. This allowed ecosystems to flourish, providing ample food and shelter for these incredible creatures. The reign of the dinosaurs seemed destined to last for eternity. However, nothing lasts forever. The stability that had allowed them to thrive would eventually be disrupted. Around 66 million years ago, something dramatic happened, something that changed the course of life on Earth. An asteroid impact, volcanic eruptions, or perhaps a combination of catastrophic events, led to a sudden and dramatic shift in the environment. The dinosaurs, along with countless other species, vanished from the planet. This mass extinction event wiped out nearly 75% of all Earth's species, marking the end of the Mesozoic era. This mass extinction event, known as the Cretaceous-Paleogene Extinction Event, or KP for short, remains one of the greatest mysteries in Earth's history. The evidence left behind in the geological record tells a story of sudden and widespread devastation. What could have caused the demise of these magnificent creatures that had ruled for so long? Scientists have long debated the causes, examining clues from around the world to piece together the puzzle. Scientists have put forth several theories, each with its own compelling evidence. Some point to massive volcanic eruptions that could have altered the climate, while others highlight the impact of a colossal asteroid that struck the Yucatan Peninsula. The debate continues, but one thing is certain: the age of dinosaurs came to a dramatic and sudden end, paving the way for the rise of mammals and eventually humans. The most widely accepted theory for the extinction of the dinosaurs is the impact of a giant asteroid. This theory, known as the Alvarez Hypothesis, was first proposed in 1980 by a team of scientists led by Luis Alvarez and his son Walter. They suggested that a massive asteroid, approximately 10 kilometers in diameter, collided with Earth around 66 million years ago, leading to the catastrophic events that wiped out the dinosaurs. The evidence for this theory is compelling. Scientists have found a distinct layer of sedimentary rock known as the KPG boundary, which contains high levels of iridium, a rare element that is more common in asteroids than in the Earth's crust. This layer is found all over the world, indicating a global event. A massive crater known as the Chicxulub crater lies buried beneath the Yucatan Peninsula in Mexico. This crater, which is over 180 kilometers in diameter, is believed to be the impact site of the asteroid that caused the extinction of the dinosaurs. The discovery of this crater in the early 1990s provided strong support for the asteroid impact theory. The crater measures over 180 kilometers in diameter, indicating an impact by an object at least 10 kilometers wide. The force of the impact would have been unimaginable. releasing energy equivalent to billions of atomic bombs detonating simultaneously. This immense energy release would have caused immediate and widespread devastation. The impact would have released an unimaginable amount of energy, equivalent to billions of atomic bombs detonating simultaneously. The explosion would have generated intense heat, causing wildfires to ignite across vast areas. The shockwaves from the impact would have triggered massive earthquakes, reshaping the landscape and causing further destruction. The immediate effects of the impact would have been catastrophic. The explosion would have ignited colossal wildfires that swept across continents, consuming everything in their path. The intense heat and shockwaves would have caused widespread destruction, leaving a trail of devastation in their wake. The explosion would have ignited colossal wildfires that swept across continents. These wildfires would have released massive amounts of smoke and soot into the atmosphere, further contributing to the global shroud of dust and debris that blocked out the sun. Earthquakes of unimaginable magnitude would have reshaped the landscape. The force of the impact would have caused the Earth's crust to fracture and shift, leading to the formation of new fault lines and the creation of massive tsunamis. Tsunamis, towering hundreds of meters high, would have ravaged coastlines around the world. These massive waves would have swept away everything in their path, causing widespread flooding and destruction. The impact of these tsunamis would have been felt across the globe, further contributing to the catastrophic effects of the asteroid impact. The impact would have ejected billions of tons of molten rock and dust into the atmosphere, creating a global shroud that blocked out the sun. This shroud of dust and debris would have had devastating long-term effects, leading to a dramatic drop in temperatures and a prolonged period of darkness and cold. This shroud of dust and debris would have had devastating long-term effects. The lack of sunlight would have caused temperatures to plummet, leading to a nuclear winter scenario. This prolonged period of darkness and cold would have had a profound impact on the Earth's climate and ecosystems. With the sun blocked, temperatures would have plummeted, plunging the Earth into a prolonged period of darkness and cold. This dramatic change in climate would have had a devastating impact on the Earth's ecosystems, leading to the collapse of food chains and the extinction of many species. Photosynthesis, the process by which plants convert sunlight into energy, would have ceased, leading to the collapse of entire ecosystems. Without sunlight, plants would have been unable to produce the energy they needed to survive, leading to widespread die-offs and the collapse of food chains. The food chain would have crumbled, leaving dinosaurs and countless other creatures to starve to death. The loss of plant life would have had a cascading effect on the entire ecosystem, leading to the extinction of many species, including the dinosaurs. The asteroid impact theory is supported by geological evidence. Scientists have found a distinct layer of sedimentary rock, known as the KPG boundary, which contains high levels of iridium, a rare element that is more common in asteroids than in the Earth's crust. This layer is found all over the world, indicating a global event. A layer of iridium, a rare element found in asteroids, is found in sedimentary rocks all over the world at the KPG boundary, the geological layer that marks the end of the Cretaceous period. This iridium layer suggests a massive asteroid impact coincided with the extinction of the dinosaurs. This iridium layer suggests a massive asteroid impact coincided with the extinction of the dinosaurs. The evidence is clear. A cataclysmic event, triggered by the impact of a giant asteroid, led to the extinction of the dinosaurs and the end of the Cretaceous period. This event reshaped the Earth's history, paving the way for the rise of mammals and eventually humans. While the asteroid impact theory is widely accepted, it is not the only explanation for the dinosaur extinction. Scientists have long debated the various factors that could have contributed to this mass extinction event, and one of the most compelling alternative theories involves volcanic activity. Another theory points to massive volcanic eruptions as the primary culprit. These eruptions were not just any ordinary volcanic events, they were colossal in scale and had the potential to alter the planet's climate dramatically. During the late Cretaceous period, a massive volcanic region known as the Deccan Traps in what is now India was spewing out enormous quantities of lava and gases. The Deccan Traps cover an area of about 500,000 square kilometers, and the eruptions that created them were among the largest volcanic events in Earth's history. These eruptions lasted for hundreds of thousands of years, releasing vast amounts of carbon dioxide and sulfur dioxide into the atmosphere. The sheer volume of gases released would have had profound effects on the planet's climate and environment. The release of these gases would have had significant effects on the Earth's climate. Carbon dioxide, a potent greenhouse gas, would have contributed to global warming, while sulfur dioxide could have led to short-term cooling by reflecting sunlight away from the Earth. Carbon dioxide is a greenhouse gas, trapping heat and warming the planet. This warming effect could have led to significant changes in weather patterns, affecting ecosystems and the organisms that depended on them. The massive outpouring of carbon dioxide from the Deccan Traps eruptions could have led to a period of global warming, disrupting ecosystems and putting stress on dinosaur populations. This stress would have been compounded by the already changing environment of the late Cretaceous period. Sulfur dioxide, on the other hand, can have a cooling effect on the climate by reflecting sunlight back into space. This cooling effect could have created a temporary respite from the warming, but it would have also led to further instability in the climate. The eruptions could have caused short-term periods of cooling, followed by longer periods of warming as the carbon dioxide built up in the atmosphere. These fluctuations in temperature would have created a highly unstable climate, making it difficult for many species to survive. These dramatic climate fluctuations would have been challenging for dinosaurs and other creatures to adapt to. The constant changes in temperature and weather patterns would have disrupted food sources and habitats, leading to increased competition and stress among species. Rapid changes in temperature, rainfall and plant life would have put immense pressure on ecosystems, potentially leading to widespread extinctions. The combination of global warming and cooling periods would have created a hostile environment for many forms of life. The volcanic activity hypothesis is supported by evidence of increased volcanic activity around the time of the KPG boundary. Geological records show a significant increase in volcanic deposits from this period, indicating that the Deccan Traps eruptions were indeed a major event. However, the exact timing of the eruptions and their impact on the climate is still debated by scientists. Some researchers argue that the eruptions occurred too early to have caused the mass extinction, while others believe that the combined effects of volcanic activity and the asteroid impact were responsible for the dinosaurs' demise. The debate continues as new evidence and techniques shed light on this ancient mystery.